Good morning or afternoon, everyone. I see we have some participants coming in. We've got about a minute or just a tad over a minute before we get started. So please get settled and give us just a little bit of time to make sure everyone's entered into the webinar, and then we will get started. Hello, everyone. We're just going to give about 30 more seconds to make sure everybody can get into the webinar, and then we will jump right in with Stuart and get started. Let's give about 30 more seconds. Looks like our participant numbers are still ticking upwards pretty quickly here, so just give everybody a few more seconds. All right. My name is Amy Raymond. I'm the president-elect for South Texas HFMA chapter, which is in Region 9. We're pleased to be able to put on this educational series for Region 9. And today, we're excited to hear from Stuart Newsome, who is the VP of Revenue Cycle Insights at Infinix. He is going to be sharing the anatomy of AI agents, what they are, how they work, and why they matter. Quick reminder for you that if you are getting CPEs for this course, please make sure you have to stay on for at least 50 minutes when the admin checks all of the attendees and participants. So 50 minutes at least, and then you need to complete the survey that is sent to you in the next day or two. Last housekeeping item is that if you have questions, please just put them in the chat. Stuart should have time at the end to kind of go back and he will be able to answer those. I'm sure he can reach out also if he's not able to answer on the call. So without further ado, thank you all for joining. And Stuart, I will hand it over to you.
All right, thank you so much, Amy. First, I really want to say hello to everyone else and a big thank you to HFMA Region 9 for the invitation to present today. And I also want to thank all of you for making the time to join today's session. I know how busy your schedules are, especially in this climate where hospital executives are managing not just operations, but they're also looking at financial headwinds, workforce pressures, as well as constant payer changes. So this title of this session may sound a little different to you. If so, you'll hopefully understand the context by the time we get to the end. But it's entitled The Anatomy of AI Agents, as Amy well articulated. So I'll admit, I borrowed this metaphor from medicine, since it's the language that we all share in healthcare. So the goal here isn't just to teach biology, though, of course, but to break down what these digital co-workers look like under the hood, so to speak. So they don't have arms and legs, but they do have eyes that can perceive data, brains that can reason, hands that can act, and even a kind of nervous system, if you will, that allows them to work together and orchestrate tasks across your digital ecosystem. So now, why are we even talking about this? It's because we're at a real inflection point in our revenue cycles in healthcare in general. For the last few years, most of the conversations about AI in healthcare have centered around generative AI, the chat GPTs, the co-pilots of the world, so to speak. And those are valuable, but what's quietly being and happening in the past is, especially among payers, is the rise of agentic AI, an AI that doesn't just generate, but actually reasons, decides, and acts on its own. And that matters for all of us in the room because it changes the playing field. If your peers are deploying agentic AI to deny, delay, or audit at scale, while your teams are still stuck with outdated tools or manual processes, you're going to feel the imbalance directly in your revenue cycle performance. So today we're going to do three things. First, we'll establish some definitions, what AI is, what it isn't, and most importantly, the difference between generative AI and agentic AI. And then we're going to unpack the anatomy of these agents, looking at the key components that make them all work together. And then third, we'll put this into hospital context, what it means for revenue cycle leaders, how to think about adoption, and the guardrails that need to be put in place for safety, compliance, and accountability. So by the end of our time, my hope is that you'll not only understand what AI agents are, but you'll have a framework for evaluating where they might fit in your organization and where to start if you want to stay competitive in this market. So just moving to the next slide, I wanted to kind of go over kind of the reasons why this matters now. And it's very simple. The competitive landscape has already shifted. Payers aren't experimenting with AI anymore. They're operationalizing it. If you've noticed more sophisticated denials, faster audit cycles, or subtle changes in prior authorization requirements, well, that's no coincidence. These are AI-driven processes running behind the scenes. At the same time, your teams are facing pressures that are only getting worse. Staffing shortages aren't going away. Burnout is climbing. And while we've added automation here and there, things like RPA bots, macros, and decision tree scripts, those tools were never designed for the level of adaptability that this new environment requires. They're brittle. They break when forms change, when a payer portal updates, or when an exception pops up. And when they break, it's your people who absorbs the extra work. So let me give you an example. Think about how most hospitals handle prior authorizations today. You might have an RPA bot logging into a payer portal, entering the same fields over and over. Well, that works until the payer changes one drop-down menu or maybe adds a new required field. Suddenly the bot fails, and now a human has to scramble to pick up the slack, so to speak. So multiply that by dozens of payers, hundreds of daily requests, and thousands of downstream tasks, and you can see how fragile the model really is. Now, contrast that with what the payers are doing. They're deploying AI systems that don't just repeat tasks, but learn from them. And here's the critical piece. They already have decades of data. And as we all know, data is king. Whoever controls the data controls the rules of the game, so to speak. And payers have had a head start for a very, very long time. So what's different now is that AI lets them accelerate how they use that data to analyze, to act, and to enforce decisions faster than ever. So while hospitals are stuck playing catch up with outdated tools, payers are actively widening the gap. And that's why I say standing still isn't neutral anymore. It's falling behind. So the stakes aren't just about efficiency, they're about protecting revenue, maintaining compliance, as well as ensuring the patients don't get caught in the middle of a broken process. So when we talk about AI agents today, it's not in the abstract, it's not a someday conversation. It's about what's already happening and what it means for your organization if you don't keep pace. So what exactly is an AI? So I want to start by saying what AI really isn't. So before we go too far into what AI agents are, I just want to pause and be clear about what they aren't. Because one of the most common mistakes I see in boardrooms and vendor pitches is that everything gets called AI. And even if you don't draw the right distinctions, we're going to set the wrong expectations and we're going to get disappointed. Think about the tools most of us have relied on for the last decade. Macros, decision tree scripts, RPA bots. They're useful, right? Well, absolutely they are. But let's be honest. They're not intelligent. They don't adapt. They don't learn. They're very rigid. If you tell them to click three buttons in a payer portal, then they'll definitely do it, but only as long as those buttons stay exactly where you told them they would be. The minute a payer changes their portal layout, the bot breaks. You've probably already experienced this. If one field is missing or mislabeled, the process collapses. And then what happens? Well, a human has to step in. They have to fix the work, and then they usually have to call IT to get the script recoded. That's not intelligence. That's brittle automation. Now, here's why this matters. If you buy into the marketing hype that says, we've added AI to our RPA, well, what you really have is a glorified macro. You're going to hit the wall. You'll be disappointed because you'll be expecting adaptability, reasoning, and improvement, and none of that will be there. So automation is repeatable. AI is adaptable. That's the clean line. Automation can repeat a task forever as long as there's nothing that's going to change. And then AI can actually handle the nuance, exceptions, and even the incomplete data. And it gets better the more it sees. So when we talk about AI agents today, I just want to put aside in your mind that mental picture of pots. I'm sorry, that of bots that only run when you hand them a certain playbook. So this is different. These systems are designed to figure things out, to make choices, and even to learn. And that's a world apart from the static automations that we've been leaning on in the past. So when most people hear the word AI right now, they think about generative AI. ChatGPT or Copilot come to mind. For most people, probably use those applications. Maybe it's Claude, maybe it's another application. These tools are very powerful, and they've captured our imagination because they can create something new for us. Maybe it's a paragraph, an image, a piece of code. They do that by recognizing patterns and massive amounts of data and predicting what comes next. But here's the catch. Generative AI is reactive. It waits for a prompt. You tell it what you want and it gives you an output. Now that's incredibly useful for tasks like drafting an appeal letter, maybe creating a patient-friendly denial explanation, or even helping with documentation. But the scope is very narrow. It's a single task completed once based on what you asked for, and it definitely has its place. Now compare that with what's called agentic AI. Now, agentic AI doesn't just create something new, it acts. It takes in data, reasons about it, makes decisions, and then executes across multiple steps, often without further human input even necessary. And here's the critical part. It can do this again and again, learning for the outcomes to refine its behavior. So think about the revenue cycle, for instance. Generative AI might help you write a beautiful worded appeal letter, but an agentic AI system could take a faxed referral, categorize that referral, extract the data, check for eligibility, initiate the prior authorization, and update the EMR, all without you even having to touch it. And that's not a one-off creation. That's a multi-step workflow executed end to end. But of these approaches have value, but they serve different purposes. So generative AI is the author. It gives you creative output when you ask. Agentic AI is, you want to think of it as an operator. It runs the process. It makes decisions and it adapts when conditions change. And together they form the foundation of what you're starting to see in healthcare operations today. So when I use the term AI agent, so to speak, I want you to think in terms of agentic AI, systems that reason, act, and improve, because that's what's reshaping how healthcare organizations are managing complexity. So at the center of both of these concepts of generative AI and agentic AI, and they're more than just concepts, they're in place today, is the same engine. And many of you have probably heard about these. You probably even know more about these than I do, but they're large language models, or as everyone else calls them, LLMs. So think of an LLM as a brain that's been trained on billions of examples of language and data. It knows how words connect, it's how context shapes meaning, and how to reason through ambiguity. So generative AI taps into that engine to create. You feed it a prompt, it pulls from the patterns it has learned, and it's made, it can generate text or maybe a code or maybe even an image. So that's why tools like ChatGPT feel so natural. They're leveraging the LLM's ability to predict the next best word or phrase. Now, on the other hand, agentic AI, though, uses the same engine in a different way. Instead of stopping at generation, it embeds the LLM into a decision loop. The model interprets the data it's given and reasons about the context, and then it helps the system choose the next best action. So once that action is taken, the outcome feedbacks into the loop, strengthening further decisions for the future. So I think you get the picture there. So you can think of it this way. Generative AI is like a typewriter powered by an LLM engine. Now, it's brilliant at producing content on demand, but agentic AI is like a self-driving car that's powered by that same engine. It doesn't just describe the road, it actually drives you from point A to point B, adjusting it along the way, and most importantly, make sure you get to where you want to go safely. Both rely on LLMs. Both benefit from their ability to understand language and context, but the one stops at creation while the other carries through to execution. And that's why LLMs are the beating heart of everything we're going to talk about today. Because if you understand that core engine, you can see how it enables the anatomy that we're about to unpack. Now, that we've laid the foundation with AI, what it isn't in the role of a large language models, I want to shift into a metaphor that frames today's discussion, and that is the anatomy of an AI agent. It's actually in the title of the presentation. So I use the anatomy metaphor because it's very familiar to all of us. We all know how the human body works. Different systems, different organs, each with their own roles, but connected into one whole that's far greater than the sum of its parts. AI agents work exactly the same way. They don't just have one function. They have different body parts, if you will, that allow them to perceive, reason, act, communicate, and coordinate. So let me outline the five that we're going to focus on today. And certainly these aren't exhaustive, and then you can use other analogies, but to me, this fit well with how my brain works. So first is the eyes. So this is where perception happens. It's how the agent sees the world through data inputs. It could be PDFs, HL7 feeds, scanned forms, anything that's on a payer portal. Without good perception, nothing downstream is actually going to work. Next, there's the brain. This is where reasoning lives. It's the decision-making center that makes those inputs, interprets them, and then decides what to do next. Then comes the hands, and this is the execution layer. It's how an agent actually acts on a decision, whether that means entering data into an EMR, submitting a claim, or clicking through a payer portal. And then fourth are the ears. Now, this is the conversational interface, how agents interact with humans in real time through chat, voice, or natural language. And then finally, we're going to talk about the nervous system. This is the orchestration layer, the connectivity tissue that ties everything together. It's what allows multiple agents and humans and systems to coordinate seamlessly. Now, of course, these aren't literal body parts, but the metaphor is useful because it gives us a way to understand the architecture. And just like in healthcare, when one system is weak, the whole body feels it. So with that overview, let's zoom in and start with the eyes, because perception is where everything actually begins. So when we talk about the eyes of an AI agent, we're talking about perception, how it sees and understands data. And healthcare data, as everyone here knows, it's pretty messy. Referrals still come in by fax. Prior authorization requests are PDFs with handwriting on them. Lab results flow in HL7 messages. Even payer portals have their own quirks. Now, technologies like OCR and NLP have been around for a couple of decades now. They're very useful, but on their own, they're limited. OCR can convert text from an image, and natural language processing can interpret clinical language. But they're tools, they're not intelligence. What makes AI agents different is that they leverage those tools as part of a broader perception system. And the agents doesn't just read the page, it understands the context. It can tell the difference between a referring physician and an ordering physician. It knows which string of numbers is the MRN and which one is the CPT code. And it can do this at scale across thousands of pages consistently without fatigue. And this is where perception becomes foundational. If the eyes don't work, nothing downstream works. A misread code here leads to a failed eligibility check later. A missing patient detail causes a prior auth to stall. It's garbage in, garbage out. That's the old adage that's been around for many, many years. But when the eyes are sharp, everything downstream accelerates. Imagine an agent taking in a batch of fax referrals, automatically categorizing them, extracting the relevant information, and then posting it directly into the EMR. No staff time, no keystrokes, just clean, structured data feeding the rest of the workflow. So yes, OCR and NLP are part of the toolkit, but the power is in the agent and how it orchestrates perception, applies context, and prepares the data for intelligent action. That's the difference between an old tool and a new coworker. So if the eyes of an agent are about perception, taking in data from the outside world, then the brain is where the real intelligence actually works. And I just want to make sure I'm on the right slide here. Yep, I believe I am. Yep. So just think about your organization for a moment. Every day, thousands of decisions are made in revenue cycle. Does this referral have all the required fields? Is it the patient's ability for services? Does the diagnosis code justify medical necessity? Do we initiate prior authorization now, or is it not required? And then if it is required, which payer portal do we go through and what documents do we need? Humans make these decisions constantly, all day long, every single day. But the truth is, most of them follow patterns. We don't really reinvent the wheel every time. We learn from experience, we recognize context, and we know what the right next step should be. And that's what the brain of an AI agent is designed to replicate. At its core, the brain combines different forms of intelligence. It pulls from LLMs, which are incredible at understanding context and language. It applies machine learning models that have been trained on historical outcomes, what's been approved, what's been denied, what led to the delays. And it layers in those heuristics and rules when they're relevant, because sometimes the shortest path is just following a clear standard. Sometimes just keeping it simple is the best way. But here's the difference between this and the older automations. In the past, we would have built a rules engine. This field is X, and then it does Y. And that works up to a point, but it doesn't scale when there's nuances. So the brain of an agent doesn't just follow a static rule, it weighs the inputs, considers the context, and selects the best action. And then over time, as it sees more outcomes, it learns which choices lead to success and which don't. So let me give you an example. Imagine an agent is processing a referral for a cardiac MRI. So the eyes extract the patient demographics, the CPCO code, and the diagnosis. So the brain steps in and says, well, based on this payer, this diagnosis and this CPT prior authorization is generally required. But it doesn't stop there. It knows that for this particular payer, approval is more likely if certain documentation is included. Maybe the most recent echocardiogram, for instance. So it flags that requirement or even prompts the system to retrieve it. Now, that's not just following a checklist, that's reasoning based on context. So this is where the value multiplies because the brain isn't just executing one decision, it's chaining those decisions together, like a clinician reasoning through differential diagnosis. And when you scale that across thousands of cases, the impact is enormous. Now, here's another way to think about it. If the eyes are about data accuracy, getting clean inputs, then the brain is about data utility. It's what transforms raw information into actionable plan. Without the brain, the eyes are just scanners. With the brain, the system becomes a decision maker that drives the workflow forward intelligently. And again, speed and consistency matter here. A human brain gets tired. After the 100th prior auth request of the day, context slips. Maybe a detail is missed. Maybe fatigue sets in. Well, an agent's brain doesn't fatigue. It applies the same reasoning at 8 a.m. and at 8 p.m., and it can do it thousands of times an hour. So when you talk about the brain, we're talking about the piece that elevates agents above old automation. It's the part that reasons, adapts, and learns. It's what turns a pile of data into the right next step. So next we have the hands. So far we've talked about eyes, we've talked about which perceive, and the brains, which reasons and decides, but as in the human body, a decision without action doesn't get you very far. So that's where the hands of the agent actually come in. And that's the execution layer. So the hands are how an agent actually does the work. Once the brain decides the next best step, the hands carry it out reliably and at scale. And in healthcare, this is where we feel the most pain with manual processes today. Staff are still logging into payer portals. They're keying patient information by hand. They're uploading documentation and moving data from one system to another. And that's if everything works well and the technology lines up. It's very repetitive, it's time consuming, and it's prone to human error. So especially when it's the 100th prior authorization of the day. So what makes the hands powerful is their flexibility. They don't just rely on one method. If there's a clean API available, the agent can post directly into the system. If the workflow requires an HL7 or FHIR messaging, then the agent can handle that. And yes, if a payer only offers a portal, the agent can even navigate the UI, click the fields, and submit the request. But unlike a traditional RPA bot, it doesn't fall apart the moment something changes. That's because the hands aren't working in isolation. They're guided by the brain, which understands the context and adapts when things look different. So let me give you a scenario. The brain determines that prior authorization is required for that scheduled MRI that we talked about earlier. So the hands then step in to carry that out. They log into the payer portal, they complete the required fields, they attach the clinical documentation, and they hit submit. But here's the difference. If the portal changes the sequence of fields, or if a new document requirements that pop up, then the brain notices it and the hands adjust in real time. And that's what elevates this beyond brittle automation. And remember, this isn't just about prior auth. The hands can move across revenue cycle entirely by posting payments into your patient accounting system, perhaps updating eligibility status, recording claims, even pushing denial codes into dashboards. Anywhere data needs to be entered, moved, or updated, the hands can do the work. Now think about the impact. For staff, it means fewer hours wasted on keystrokes and clicks, and more time focused on exceptions or patient-facing tasks. For organizations, it means speed, accuracy, and scale. And for patients, it means fewer delays caused by paperwork bottlenecks. So there's another point here that's worth emphasizing as well. So we often underestimate how much mental weight repetitive work creates. Staff doing data entry aren't just spending time, they're spending cognitive energy on tasks that don't use their full skill set. By shifting that work to the hands of the agent, you're not just increasing throughput, you're improving morale, reducing burnout, and giving your people room to use their expertise where it matters most. So if the eyes are about perception and the brain is about reasoning, the hands are about execution, making sure that the decision actually turns into action. And just like in the body, the system falls apart if the hands don't work. But when they do, you can unlock a level of scale and efficiency that human teams alone simply can't match. So now there's one more piece that makes this system truly useful in the healthcare setting. They have to be able to listen and communicate with us. And that's the role of the ears. So the ears are about interaction, the conversational layer, if you will. So in practical terms, this is how the agent engages with human staff in real time. Sometimes that's through a chat interface built into your EHR or workflow system. Sometimes it's through voice, like a digital assistant that can answer questions over the phone. And sometimes it's embedded in applications where the agent listens for instructions and provides updates on status. Here's why this matters. Most hospital executives and revenue cycle leaders I speak with don't want another black box system making decisions with no transparency. They want visibility. They also want accountability, and they also want a way to interact with the system. And the ears provide that bridge. So let me give you a simple example. Now imagine a staff member is wondering whether a prior authorization has been initiated. Instead of digging through a portal or making a call, they can just type, has the auth been submitted for Mr. Johnson's MRI? Well, the agent using its ears hears that question, checks the workflow and replies, yes, it was submitted yesterday and here's the confirmation number. That's not science fiction. That's actually interaction. Or take scheduling. A call center rep could ask the agent, well, what's the next available slot for a CT scan that meets this patient's insurance requirements? And the agent listens, reasons with its brain, and then answers in plain language. This is powerful because it shifts the relationship. Instead of staff bending over backwards to understand software systems, the agent adapts to staff, listening, responding, and assisting in human terms. It makes the technology feel like a coworker, not a barrier. So there's also an important governance angle here. The ears create a record of communication. Every interaction, that means every question, every answer can be logged. That means you have audibility and you know who asked what and when and how the agent responded. So it's a compliance heavy industry like healthcare. That transparency isn't optional, it's actually required. And let's not underestimate the cultural piece here. Staff adoption of new technology often hinges on comfort and usability. If the only way to use an agent was to hard code workflows or sift through dashboards, uptake would lag. But when you can simply ask in your own words, the barrier to entry falls dramatically. People start to trust the system because it feels natural to work with it. So when you say that the ears matter, it's not just about adding a chat window. It's about making agents approachable, accountable, as well as transparent. The ears are what an agent from all invisible background systems into a real partner at the elbow of your staff. So next we're going to talk about the nervous system. And we've now seen how an agent can perceive with its eyes, reasons with its brain, uh, takes action with its hands, and communicates with its ears. But all those pieces worked in isolation. you just have a set of disconnected functions. What makes an AI agent truly powerful is the nervous system, the orchestration layer that connects everything together. So think about the human body. Again, I've asked that question before. Your eyes don't just take in light on their own. The information has to be transmitted through the nervous system to your brain, which processes it, then signals it to your hands to act. Without the nervous system, the body parts just don't coordinate. The same is true for AI agents. So in a hospital context, the orchestration is what turns a set of discrete tasks into an end-to-end workflow. The eyes might capture data from a referral, the brain decides whether prior authorization is required, the hands log into the payer portal to submit the request, and the ears answer a staff member's question about the status. So the nervous system is what keeps that flow synchronized, making sure the right steps happens at the right time with the right data handed off. And here's why this actually matters. So healthcare is a web of interconnected processes, and we all know this. Eligibility ties into scheduling. Prior auth ties into medical necessity. Claims tie into denials management. If each of those lived in silos, you'd spend all your time firefighting handoffs. Orchestration solves that by ensuring that the agents aren't just task doers, they're team players. And it doesn't stop with technology. The nervous system also manages coordination between agents and human staff. Maybe an exception comes up that requires a nurse's clinical judgment. Well, the agent doesn't just stall or break, it routes that case to the right human, flags what's needed, and then resumes once the input is provided. Now that's orchestration. It's also about governance. The nervous system creates a central record of what happened, when, and why. If you ever need to audit a process or track why a claim was submitted a certain way, well, you can see the full path. That transparency is essential for compliance and trust. And then one more point before we move on. And I want to talk about scalability. Now, in a small clinic, maybe one agent could handle a process end to end. But in a hospital system, you may have multiple agents, one that specializes in intake, one in eligibility, one in prior auth, one in payment posting. The nervous system allows them to coordinate like a relay team, passing the baton smoothly so the overall workflow keeps moving without gaps. So if the eyes, brain, hands, and ears are the building blocks, the nervous system is the connective tissue that brings them to life as a whole. And that's what makes an AI agent more than the sum of its parts. It's what allows these systems to fit into the real complexity of healthcare operations. Now that we've gone through the anatomy, so to speak, of the eyes, brains, hands, ears, nervous system, so to speak, the natural question is, how does all of this actually work together in real time? And that's where the life cycle comes in. An agent isn't just a collection of parts. It's a living loop of perception, reasoning, action, and learning. And if you understand this cycle, you'll understand why these systems don't just repeat tasks, but actually get better the more they're used. So here's how it flows. It always starts with intake. The eyes, data comes in, like say a referral, an eligibility request, a payer status update. That information gets captured, structured, and then passed into the system. From there, there's the understand phase that kicks in. So the brain interprets the data. What does this referral mean? What's the diagnosis? What payer is involved? What's the clinical context? It implies reasoning to make sense of the inputs. And then comes decide. This is where the brain chooses the next step. Do we need prior authorization? If yes, which portal? If no, then we can route this directly to scheduling, right? Well, the decision is contextual. It's not just rules, it's judgment based on patterns and outcomes. And then after that, we move to action or act. And this is the hands, like I illustrated earlier, that executes the chosen action. They log into the payer portals, or they post eligibility checks, they submit the prior auth, or perhaps even just update the EMR, EHR. Now, this is the work being done at scale. And then finally, there's learn, because this is critical. This is what sets agents apart. The system doesn't just act and forget. It looks at the outcome. Did the claim go through clean? Did the prior auth get approved? Did a denial come back? And then it feeds that outcome back into the reasoning process, refining future decisions. That feedback loop is what makes these agents dynamic. With every cycle, they get smarter. They learn payer nuances. They learn provider preferences. They learn which data elements make a or break an approval. And the more cycles they complete, the stronger and faster they become. Now let's connect this to your organization. Now imagine an agent processing thousands of prior authorizations. At first, it's using baseline knowledge, but over weeks and months, it starts to recognize that for a certain payers, approvals are 20% faster when specific clinical notes are included. So it adapts. It starts requesting or retrieving those notes automatically. That's learning in action. The beauty of this life cycle is that it's continuous. Intake leads to understanding. Understanding then leads to decisions. Decisions lead to actions, and then actions lead to outcomes. Outcomes drive learning. And the cycle repeats again and again, getting sharper every single time it runs. So if you think about it, this mirrors how humans grow in expertise. A new revenue cycle specialist might follow a checklist. Over time, they see enough edge cases to know what works and what doesn't. They develop judgment. AI agents are doing the exact same thing, but they're doing it at a machine speed with perfect recall across volumes no human can handle. So when I say AI agents aren't just automation, this is what I mean. Automation stops at action. It clicks the button, it submits the form, but agents complete the loop. They act and then they learn. And that's what makes them intelligent. And once you see the life cycle in action, you can start to imagine the potential. It's not just about automating one step. It's about building a system that continuously improves, scaling your capacity without scaling your headcount. Now, we've seen how agents can perceive, reason, act, listen, and orchestrate, but let's be clear about something. They aren't here to replace people. I know many of you have probably heard that before, but it is absolutely true. They're here to work with people. So this is where a lot of the misconceptions about AI actually come in. There's still a fear out there that these systems are meant to take over jobs, to hollow out teams, or to reduce headcount. But that's not what's happening. AI agents are at their best when they complement the staff, so to speak. So taking on repetitive tasks, rules-driven work, so humans can focus on exceptions, the judgment calls and the patient interactions that truly require expertise is what those humans specialists would actually interact with. So here's what that looks like in practice. So imagine a patient access team, okay? I don't know if you've ever been on a patient access team, maybe you run a patient access team, whatever the case may be. So the agents handle the routine eligibility checks, the repetitive prior auth submissions, and the constant portal lookups. Staff step in when something doesn't fit the mold, maybe a payer rejection that needs a clinical justification, or maybe it's a unique case that requires escalation. The agent takes 80% of the volume, and the staff focuses their energy on 20% that really requires human judgment. So there's that exception rule. And here's the hidden benefit. By shifting that repetitive work away from humans, you're not just increasing efficiency, you're reducing burnout. Now, we underestimate, as I said earlier, how mentally draining it is for staff to spend hours every day typing into portals, correcting denials, or rekeying data. Now, when you let the agent handle that, you're not only improving throughput, but you're improving morale. So there's also a governance benefit here, and we touched on this a little bit before, and we're going to go do a little deeper dive into governance a little later in a slide. But agents can be programmed with boundaries. They don't go outside their lane. They don't make clinical decisions. They don't override human authority. Instead, they stay in the swim lane of repetitive rules-based work, and they hand off to staff whenever exceptions or judgment calls arise. So this is important for adoption. Staff need to trust the technology. They need to know that it's not going to suddenly replace them, but instead make their jobs better. And when they see that in action, when they realize that they don't have to spend their day clicking through the same portal screens, adoption does accelerate. They start to see the agent as a partner, not a threat. Think of it as a division of labor. Agents are consistent, scalable, and tireless. Humans are empathetic, creative, and able to navigate ambiguity. So together they form a workforce that's stronger than either could be alone. So when I say agents and humans work together, I mean it literally. The future of the revenue cycle isn't man or machine, it's man and machine, and each doing what they do best. And that's how organizations will get the most value out of the technology. So sometimes the best way to understand how AI agents work is to walk through a day in their life. So let's do that together. And I'll frame this as if we had an agent embedded in your revenue cycle or organization. So I'm just checking the time real quick to make sure we're on point. Looks like we are. So it's 8 a.m. in the morning. A new batch of referrals has come in overnight. The eyes get to work immediately. They're scanning the faxes, they're categorizing each referral, they're extracting the patient details, the diagnosis codes, and the CPT codes. By the time your staff are logging in for their day, the referrals are already digitized and structured, ready to move downstream. Next, the brain takes over. For each referral, it checks, is prior authorization required? If the answer is no, it sends the order straight to scheduling. If the answer is yes, it determines which payer, which portal, and what documentation is needed. This isn't a rigid yes/no decision, it's contextual reasoning based on payer rules, diagnosis, and historical outcomes. Then the hands step in. They log into the payer portal, complete the fields, attach the necessary clinical documentation, and submit the prior authorization request. But here's the difference. If the portal has changed since yesterday, maybe a new dropdown was added or a sequence of fields shifted, the agent adapts in real time. It doesn't break the way a static bot would. So midday, the ears get involved as staff members wants to know whether Mrs. Garcia's CT prior auth has been submitted. Instead of hunting through portals, they simply ask the agent in a chat window, has the CT auth been filed? And the ears listen, the brain checks, and the agent replies, yes, it was submitted at 10:14 a.m. Here's the confirmation number. And that's collaboration in action. So by afternoon, the nervous system is at work coordinating across multiple processes. Eligibility checks are feeding into scheduling, prior auth status updates are flowing into the EMR, denial codes are being captured and flagged for follow-up. The nervous system keeps the flow smooth, ensuring that the data and the tasks move to the right place at the right time. Now imagine scaling this across hundreds of cases in a single day. What used to require dozens of staff hours is now being handled automatically with staff stepping in only for true exceptions. The agent has worked a full shift without fatigue, without errors, and without needing a break. And the impact isn't just internal, it's for the patient as well. This means fewer delays in scheduling, faster turnaround on authorizations, and less frustration with paperwork bottlenecks. And then for the organization, it means reduced cost, improved throughput, and then better compliance. And for the staff, well, it means a shift from repetitive drudgery to high value tasks that actually use their expertise and their skills. This is why I like to frame it as a day in the life, because it makes clear that agents aren't abstract concepts. They're coworkers working today. They start the day, they do the work, they hand off to humans when needed, and they keep improving over time. So when someone asks, what does this look like in practice? This is the picture that I'm trying to paint. It's not about flashy demos or hypothetical someday solutions. It's about real workflows today running smoother because an AI agent isn't on the team. Or rather, I would just say the AI agent is on the team. So next, I just want to touch real quick on guardrails and governance. So whenever I talk about AI in healthcare, there's one question that always comes up, and it's usually about compliance officers, or it usually comes from some attorneys or legal counsel. Since I'm a CPCO, I tend to gravitate to this as well. So the question is, how do we keep this safe? Because as powerful as these systems are, we know healthcare doesn't leave much room for error. And that's where guardrails and governance actually come in. Just like a powerful tool, AI agents need boundaries. They need rules of engagement that keep them in their lanes, ensure transparency, and protect patients and organizations alike. So let's start with privacy and HIPAA compliance. Agents are handling PHI every time they take in a referral, every time they check eligibility or submit an authorization. That means encryption, audit logs, and strict access controls aren't optional. They're built in from day one. So the same standards that apply to staff handling PHI have to apply to agents as well. And second, there's bias and fairness. We know AI can amplify bias if it's not monitored. So part of the governance is testing agents regularly. Are they making consistent decisions across patient populations? Are they unintentionally introducing disparities? This is where audit trails and monitoring matter so that the leaders can see not just the outputs, but the reasoning steps behind them. And then third, there's human oversight. Agents should never be designed to run unchecked. They should have escalation paths where exceptions and ambiguities and as well as high risk scenarios go straight to human reviewers. The government's models make sure humans are always in the loop for judgment calls that require clinical or ethical reasoning. And then finally, there's accountability. One of the benefits of agents is that they can create a record of every action they take. Who triggered the workflow? What data was used? What decision was made? What action was followed? And what outcomes resulted? That creates a full chain of accountability that is often more transparent than what is actually happens in the manual process. And a regulator asks why a claim was submitted in a certain way, then you can show the digital footprint step by step. So I'll frame it this way. Guardrails aren't just about protecting against risk, they're about building trust. So staff start trust that the agent won't really overstep. Executives trust that the system is compliant. Patients trust that their data is safe. Now, without that trust, adoption will stall. With it, adoption accelerates. So as exciting as the anatomy of life cycle of an AI agents are and what I've just discussed, none of it matters without governance. Guardrails are what makes this technology usable in the real world. They're not an afterthought, they're actually foundational. So let's step back for a moment and look at the mechanics of looking ahead. Where is this all going? Where does the future of AI agents in healthcare look like? Well, right now, most organizations experimenting with agents are deploying them in a very focused, narrow use cases like prior authorizations, eligibility checks, and maybe even some document intakes. That makes sense. So you start small, you build confidence, you prove the value. But just like any technology curve, what begins narrow eventually broadens. And in the near term, we'll see multi-agent ecosystems. Instead of single agents handling one slice of the workflow, you'll see specialized agents working together, one for intake, one for eligibility, one for prior auth, one for claims follow-up. Each does its part, and the nervous system orchestrates them in an end-to-end process. So beyond that, we'll see agents expanding into clinical and operational workflows like scheduling optimization, patient outreach, even clinical trial matching. The same anatomy that we've described applies across many different paths of healthcare, not just revenue cycle. So once organizations build comfort in one domain, they naturally move is to really extend it into some of the others. And another piece of the future is predictive and prescriptive capabilities. Right now, agents are mostly reactive. Intake, make a decision, take action, but with enough cycles under their belt, they start to anticipate. Now imagine an agent flagging that a claim is at high risk of denial before it's even submitted, or predicting which prior auths are likely to get rejected unless additional documentation is included. That's prescriptive power, not just reacting to the present, but shaping the future. And then there's the broader landscape. Payers are already deploying these systems aggressively, as we spoke about in the beginning. That means providers will have to keep pace, not just to remain efficient, but to remain competitive. We're heading toward a world where revenue cycle performance is much about your digital workforce as your human one. Organizations that build agent ecosystems will see measurable advantages in throughput, accuracy, and as well as cost control. And those that don't will be forced into constant catch up. Now, I want to emphasize something here. The future isn't about replacing staff with machines. I know we talked about this earlier, but it's worth repeating. It's about augmenting capacity. Every hospital executive knows how hard it is to recruit, train, and retrain skilled revenue cycle staff. Agents aren't about shrinking teams, they're about stabilizing them. They take the load off so that your people can focus where they add the most value. And that's the model that scales. So if you think about the trajectory, here's the picture. Today, targeted use cases. Tomorrow, multi-agent ecosystems across the revenue cycle. Beyond that, we have predictive and prescriptive intelligence that reshapes how organizations manage risk and optimize performance. And then ultimately, it's a future where your digital workforce is critical a part of your organization as your human workforce. And that's the outlook. And it comes faster than most of us are really realizing. So one last slide, and then we'll get to questions. But here's basically what I'm talking about. We've covered a lot of ground and what AI agents are, how they work, and why they matter. But I want to end with something very practical. What do you actually do with this information? Because the goal of today isn't just education, it's to prepare you for action. So think about this in 3 steps. First, you want to explore. That means taking a hard look at your organization's workflows and identifying where the pain points are. Where is staff burnout the highest? Where do errors or delays create downstream revenue risk? Where are your payers already outpacing with you in their use of AI? These are your high value use cases. Now, for many hospitals, that's prior authorization. Maybe it's eligibility verification or document intake. For others, it may be claims follow up or denials management. The key is to pick the spots where an agent could deliver immediate, visible impact for you. Step two is pilot. Now, this isn't about boiling the ocean. It's about picking one use case, one department, or one payer relationship and testing the waters. You define clear metrics. Maybe it's reduced turnaround time, fewer denials, improved staff satisfaction. And you run a pilot with a defined scope. This gives you data to prove value and lessons to refine governments. Just like with any clinical program, you don't start system wide. You run a trial and then you learn and adjust. And then there's step three, and that is scale. Once you've proven value, then you can expand. You connect more workflows, deploy more agents, and start building that digital workforce alongside your human workforce. But you do it with intentionality, with governments in place, with staff engagement, and with metrics you can report up to the board. Scaling isn't just about technology adoption. It's about cultural change where staff see agents not as threats, but as teammates. So let me put it this way. The organizations that win with AI won't be the ones who dabble. They'll be the ones who move with purpose, exploring where agents fit, piloting carefully, and then scaling deliberately, all with a level of responsibility. And the time to start is now, because payers aren't waiting, as we've discussed. Technology isn't slowing down. I can tell you that in the last 6 months, I've seen more advancements in technology than I have probably my 30-year career in healthcare. And the only question is whether providers will take the same deliberate steps to remain competitive. So as you leave today, just ask yourself, where could we start? And what's the first workflow that we could explore? Who are the champions on our team who could help us pilot? And what would it take for us to scale this across our entire enterprise? So that's the roadmap. It's very simple. Explore, pilot, scale. It's not flashy, but it is actionable. And sometimes you have to start simple and keep it simple to take action and move forward. So, and it's how you position your organization for the future that's already arriving. So with that, I do want to now turn it over to Q&A, but we've talked about a lot of stuff here in the past hour. But for the most part, today it's been my voice you've been hearing, but now I want to hear your voice. I really love talking with people about how they're doing things today, where they're having issues. And I'm also love hearing people how they've actually solved those issues, because it's all about sharing, it's all about collaboration. So with that, I just want to hear what's on your mind. So yeah, Rachel, I'll turn it over to you and see if there's any questions.
Yeah, there are a couple in here. So if one of these was already answered, please let me know. But the first question I have here is, how do you create agents, or where can you find pre-made agents?
Oh, that's a great question. And there are, certain agents and corporations out there that you can grab an agent off the shelf. There are certain companies that will use predetermined created agents that's off the shelf and they plug and play it inside of their workflows. ChatGPT 5 is a good example where there's a lot of agents that are leveraging ChatGPT 5 in the background. So you're dependent upon open AI, so to speak. But I think the best approach is, find someone who's an expert in this. Find someone who can listen to what you're trying to accomplish. Um, Typically, everyone has similar problems that I hear, but there's also uniqueness to those problems. Everybody I speak to may have the same issues, but they have different workflows. And it's all about trying to match their workflows, not totally change wholesale everything they're doing. So it's very important that when you have these agents, you can build those agents out or have those agents built out by a consultant. There are organizations that are doing their own agents, like Mayo Clinic, for instance. They have the resources to do so. Not everyone has the resources or the time to do so. So it's very important to find a trusted vendor. I can go and speak for another 30 minutes on that process. But here in Infinix, we obviously do, have AI agents. We do like to build our accounts, so to speak, our processes off relationships. So we'll come in, we listen to the issue, then we solve that particular issue. And just like I outlined in the presentation, we will expand where are some other areas that we can expand this into. So it's just like you would evaluate any other vendor, you just need to educate yourself. I'll be happy to talk to you individually about how to do that. whether it's Infinix or whether it's someone else, be more than happy. There is some certain criteria and best practices in going about doing that.
Thank you, Stuart. And I do have another question here. Are more payer contracts beginning to reflect incorporation of AI utilization? Is there anything to be especially attentive to or cautious about?
Yeah, I think some of the early examples that I can remember that was just about 9 months ago, we just saw a big influx of requests for medical records. Infinix is an end-to-end RCM service. We deploy AI and agents to help our internal team do the work, but we also deploy them as platforms. And I say all that because we saw a spike in requests for medical records. And when we dove deeper into it, it was really more about, wow, they're using AI to go back and track these at a much accelerated rate, where it was this kind of steady flow. Everyone gets these requests. So it's nothing new. But when it spiked, we were very alarmed and we just dissected the problem that they were using AI to actually go back and request all these medical records at a much faster rate. Because remember, data is king. Healthcare insurance payers have been sitting on data for decades and decades. And now they just have a better flexibility and better tools to leverage that data much faster. So they're not doing anything any different than they were before. It's just coming at a much faster rate. They're also using AI to determine certain medical necessity levels because as anyone's ever communicated with payers, sometimes they operate in silos as well. So they're actually using AI to better incorporate their policies. Um, and they're using AI to look at the behavior of that data in order to come in and negotiate contracts. So if you want to take it to the negotiation step, you want to be sure that you're leveraging the same type of technology the best you can in order to approach the table with negotiating with the same amount of data that you can counter those contracts. If there's anything you're doing in those negotiations to help, because they're using that data and AI to crunch that data in order to have leverage during those negotiations.
All right, we have two more questions. We'll try to get to these. So the next one is, are there, oh, I just lost it. Hold on one second here. Are there how do you deal with how do you deal with patients potentially pushing back to the use of AI in outpatient and inpatient visits?
Oh, wow, that's a good one. Because I think it's getting better. I think at first there was this fear even in patients' world if they caught on to the fact that AI was being used on them, there's still this, oh, it's AI is taking over the world. Machines are going to take over the world. And you get into like films like Terminator and stuff like that. But I think as the public's getting more educated and adopting AI themselves, they can see the benefits. Many times they can encourage it. I think it's just educating them about how you're leveraging AI if that question comes up, that it is protected, making sure that you have those safeguards. Because remember, as I said earlier, you want to be sure that you're regulating the technology of AI agents the same way you would your human specialists, your human personnel, your staff. If they're handling PHI and that patient data, then they need to be reassured in your privacy statement that it's going to be protected, and any breach will have serious consequences.
Okay, we have a few more minutes here, so let's try to sneak in some more. Are there AI RCM products available and reasonably priced for small practices, for example, less than 5 clinicians, and how can we find them?
Yeah, that's a great question because I know in many cases, the AI technology still can be pretty expensive. It's not cheap, to develop. I know we have an immense staff ourselves, led by a chief data scientist that she does amazing work, along with our chief product officer and an immense team of minds that work on our agents. So it does require an investment. It may be something that gets less expensive as time goes on because every new technology is really expensive at the beginning. For practices that are 5 providers or less, the ROI may not be there. at scale. I'm just being very transparent about that. But there are some things you could probably do on your own that again could probably take another 30 minutes or so. So if you want to reach out to me, I'll be happy to collaborate with you on that for sure.
Okay. Well, some more questions came in through the chat as you've been speaking, Stuart, and I know we only have a minute left. So what I'm going to do is I'm going to ensure that these questions are sent to you so
Okay.
that you can respond to them. And given that we just have 1 minute left, I want to make sure that we wrap up accordingly, give you some of the housekeeping items that I know Amy probably shared at the beginning. But all of the attendees will receive a survey in 1 to 2 business days. Once you complete that survey, then you'll receive your CPE certificate. This process can take 2 to 3 business days. So I just want to make sure everyone is aware of that, but you will receive that survey. Once you complete it, you'll receive your CPE certificate. I want to remind everyone that the next webinar for Region 9 is on October 14th. The Region 9 conference, which is held in New Orleans, is going to be November 16th through 18th. So hopefully we get to see you there. And then I do have to put in a plug for the HFMA South Texas chapter. We have our annual symposium in San Antonio, September 22nd and 23rd, and we'd love to see you there as well. Thank you so much, Stuart, for this valuable information and extremely interesting topic that you shared on today. And thank you, everyone, for joining us.
Yeah, thank you for having me as well. Appreciate everyone attending.
All right, thank you. I'll get these questions over to you, Stuart.
Thank you.